Okay. Alrighty. Now we're talking about black holes. Actually, space-time, superposition, dualistic corpuscular time, particle unitizing reality setters, which are black holes. The internal part of the black hole is omnidirectional in that multiple objects can wrap around in any direction and still always be in the middle. Special property of space. And I call the whole space a space particle because if you take a tiny space particle versus a large space particle and analyze it with no frame of reference, there'll be no difference. It's what you call infinitely divisible and not comparable, really, with no frame of reference. So this is the way the black hole, this part is essential. From the formation of a black hole and the resulting effect at light speed is our space's adjustment of losing mass, and I suspect the diameter of the matter is wobbling, which I have studied and found out is true. It's like ringing the gravity bell in our space, actually showing that it fits perfectly with this model. I think a better test is an interference pattern to check for wobbles in the, or changes in the interference pattern. Really? I think what I was thinking about was time clocks. Like if you had clocks and the gravity warbles through two clocks, would it cause a bump in the timing here and here, and then comparisons between the two would show that? It might be easier to make than what they're using now. A light speed resonance shared by particle transferred through non-local, non-cancelled gravity pulses through the black hole in our space, where else would nothing travel through nothing. Let's see. It's talking about what I call V particles and P particles, or P mass. That the V particle travels perpendicular to the P particle, or in electromagnetic forces that don't extend but are there. They may extend, they may not extend. Then we've got some diagrams that are not related here, but okay, various sized singularities with rotating poles and slingshot behavior, closed door singularities. Reality is two corpuscular times, cancelled gravity through space as a single particle divided by, let's see, oh yeah, cancelled gravity through space, because every center of the space is the center. I mean, every Planck length in the space is the center. I mean, and I'm using Planck length because if you don't use some limited number, then, and there's certain aspects that may not be limited, but it depends how you look at it. But rationally, the core is divided up into Planck lengths and updated one Planck time here at a time. And there, the reunitized time, which is also part of our dualistic corpuscular time set space, particle reunitizing reality maker. So when those, let's see, yeah, so when the one Planck length is updated, it becomes whatever. Okay, so if it's space, it just is space. But if it's and how is it updated with space? It's updated by the gravity, in the sense that gravity pulls down in that Planck size, and it cancels all gravity. And I said particle is divided by the smallest possible division. It is likely Planck scale. This limiting size stops the halting problem that would otherwise occur if a quantum limit didn't exist. That's if the the update is done linearly from or serially from one end to the other, say. But I don't. There's nothing saying that that's the way it's updated. It could be updated all at the same time. So, but since the particles are reunitized, and whatever makes up the particles of particles, that's what we're looking at here. So, if it wasn't, if the particle didn't reunitize, the black hole would snuff that there'd be nothing to hold in the center of it, and since there is an attraction, the the halting problem. Okay, so anyway, what I'm trying to get at is that it depends how you look at it. There could be a halting problem, but not having a halting problem is a problem. So, but if you have a halting problem with the update, then Planck lengths would solve that, because it'd be some number that's discrete, every point in the singularity has cancelled gravity except at a base particle level. This allows the weak force to leak through that space, and so that must be happening, or we wouldn't have a weak force. So you can determine that what I'm saying is implied to be true because of what we see. Now, if you imagine that going into the black hole, you have to go through this, the spaghettification process, or practically a blender, because by the time most matter gets, when most matter's going in, it's whatever's before the neutrons, after neutrons. So whatever neutrons turn into afterwards, which is basically nucleus material. Nothing really very, apparently not solid enough to keep it from emerging into a black hole. So, except at base particle levels, this allows weak force to leak through. Then we got a diagram of cancelled gravity in the core, which is right here, and just a cube there, which isn't very good, but this gives you an idea of the arrows that are pointing to the center in each Planck length. And is the Planck length proven? Well, I don't know that it's proven, but it's a good place to start. And then gravity is quantized through mass. Quantized? Gravity alone tells us about the geometry and the curvature of space-time itself. The answer is right there. Curvature of space-time is set by the space-time setter, and that is the black hole that we never left. Each black hole has two corpuscular times, one super time and the other space-time. One 90 degrees perpendicular from the other. Energy particles flow through the axis and potential mass particles move perpendicular to that. A coincidence or cooperation, a friendly collision creates a particle, a persistent interaction is a persistent particle in our space time. In the middle of the singularity, all space accumulates. And let's see, I got something else written here. Constant update means even flow of time. Smallest time is likely Planck time. That equals one update in the core. In our space-time, in the middle of the singularity, all space accumulates, and because space has a zero density, it is indistinguishable from itself. Size is irrelevant, but I don't like to say irrelevant, but just for this purpose. But mass of the black hole is not what goes in, is what can come out or resemble in the white hole, which is us. Every black hole would be different. The moment we can't see light from the black hole is the moment the black hole has reunitized light. And all other potential particles are thus affected. Black hole, accumulated space, the core is the core space, and then the electromagnetic interactions that cause persistence, or the base. It's actually a base particle, so we really don't know. We just know what light is. And since light uses electromagnetic, and also if you look at light doesn't age, it doesn't get old like we do. So light is traveling to the max speed in this space-time. And so, but it's not aging. But if you took something that was traveling near light speed and then slowed it down, it would be not aging much. And then you slow it down, it would start aging faster. So there's like an exchange between going too fast makes it so you can update your frames, but you reduce the update of the internal processes of those particles. Interesting. Each particle is in the center from its point of view. Each particle is on its own frame of reference. And then here this is, you got A, B, C, D, E, all in their own frame of reference, all in the middle of all of space. Each one has its own perspective. And this is an extended form of relativity. A's point of view, I'm in the middle, and it sees it this way. It sees itself totally alone, but then if you look at it from our aspect, in space-time, you see the other particles off somewhere else. But if you're on one of those particles, it would be, B would be here, C would be here, D would be here, E would be, there'd be no difference from their point of view. They'd just see those particles spread throughout space in a different pattern. Space thus wraps around the particle, rather than the particle traveling through space. The limit of light ensures that the host human never knows the wraparound. I'm not sure why I put that. It's kind of spooky. This thing is omnidirectional and simultaneous because there is no edge of this kind of space, and everything is in the middle from its own point of view, and all is falling to the center of the black hole, and thus is what gravity is, and this is what gravity is. So basically, when you jump up on the planet, a singularity's pulling you back down to the center, but it's kind of a friendly pull down because it's in canceled Planck length space. So, like, because the particle of space, or all of space, which doesn't really seem like a particle, but I'm saying it for a very logical reason, which basically is this enormous space compared to a tiny one with no frame of reference is exactly the same. The only thing that's different is the energy content. And the energy content reunitized, and also the gravity itself that forms that reunitizes all the particles. So the more the gravity, the more the particles are reunitized. The more the particles are reunitized, that changes things within that dualistic corpuscular time shared space. The super time update is 1 moment in our time, and it's likely Planck time for 1 complete cycle. To my surprise, a video titled "What is Gravity?" agrees with my idea that the collision of 2 black holes causes a compression of particles that then spring back very huge evidence, like a matter bell. This helps as evidence of the time-setting nature of a black hole. In the black hole, the frame order is kept. Infinities in the quantum world by general relativity is correct. This, and I actually think it's discrete, but there are infinities. This is when you should switch to quantum relativity, which is a reunitized corpuscular time in relation to this time. It is infinite. Oh, I see what I'm saying. It's basically saying that the relativistic actions, and I have been learning more, which basically, particularly about Einstein, which that it was his let's see, general relativity that was one of them doesn't do well in space because it's curved. Well, in the core, things are different. The curvature is just like here, so it's basically flat. Why is that? Because the updates that are done in a curve form are done individualistically, and then the particle is unitized. If you think of it like the gravity well, like a straw, where all the particles are stacked just down in a line that goes on for infinitely almost, because our universe is very big. Planck length width all the way down until the whole universe is in that straw, space-wise, right? So then, but that same thing happens in one spot, but each spot is a frame, like that. So it's correct that that it is a point of singularity, but it's not correct to say that all particles are just in that same singularity. It's kind of ignorant to say that they don't retain their own individualistic being. All due respect, I'm not trying to step on anybody's toes here. I'm just trying to think through this process of my model. Which is a reunitized corpuscular time in relationship to this time. So inside the singularity, there's two corpuscular times. I don't want to bring a separate black hole in because that's 2 corpuscular times. So within this corpuscular time, you have space-time and superposition time, right? So the superposition time is reunitized differently than our time here for the update process, and that allows basically like Stephen Hawking and all those people that did work on the holograph effect on the outside of the black hole. If you take that black hole that has this information strapped around the whole black hole, like all this memory, that's interesting. It's not. Don't put it on the outside. Invert that, and guess what? You have a core. It's in the middle, and we're the core. So the information was broken down but can be reassembled into everything we are. And as far as the evaporation of a black hole, this is when we're talking about a particle being a singularity, we're not talking about an atom being a singularity. We're talking about a base particle that is the constituents of everything. As far as I'm just saying a base particle because I believe it to be about the size of a Planck length, and as far as the nature of that particle, there may be various types of conditions that are different, but I'm going to call it kind of like, just are there many reunitized particles, or is there just one? Right now we're just going with one generic reunitized phenomena inside the black hole, but everything that is stripped down to whatever it gets stripped down to will reassemble on the other side. Basically, we're going by the evidence of the 3K radio energy that was emitted by the Big Bang. The Big Bang occurred, and we know what happened there. We know a lot, and this, you can look at the heat and the gases, and then the resultant particles that were assembled. It's amazing how much we know. And that I'm not saying what I'm saying because I want to just make it up. I want to base it. I'm basing it on that. So basically, one cycle in superposition is one Planck time here. So there, one complete cycle, which may look like a wave function or a fuzzy thing or a statistical thing, is not. It might be statistical here, but there it's just an orbital. And then when you finally cause the collapse, what we call the collapse, that's just a phasing. The two corpuscular times that are out of phase end up in phase, and then when they're in phase, you get to see the particle that emerges. Before that, you're seeing what you might call blurry or fuzzy, or and even though it doesn't violate general relativity from within the singularity. So what is I'm saying? Oh yeah, because I was talking about general GR. A test. The James Webb Telescope compared to a telescope closer to Earth, like Hubble, should show exactly the same expansion in the universe, even though one is offset from the other. In other words, each will show values that are not, each will show values as if it's in the center. That's what I want to say. I got confused there, I think. Each point of the universe will seem like the center. I suspect the universe, that is to say, our space, may have a mirage effect that gives the appearance of expansion at the same rate forever. What was the expansion rate, say, in 1965 compared to now in 2024? How does space-time gravity emerge from quantum field theory physics? Space-time emerges from corpuscular time-setting system, which is a black hole. Light is reunitized and all subsequent particles are affected. One moment. Yep, we've got a little bit of time left here. Superposition is super time, and our space is space-time. These two are intimately connected. Space is one particle in the singularity, and it is indivisible. Well, it's it's a special particle, so I got a lot to say about it. One is that it's a single particle. Two is that it's reunitized by the singularity, and that's what cancels all the gravity except for the weak force. And then, and then the base particle would be the same size as the singularity. I mean, as the canceled gravity size, because that's the size that gives the discrete value of the universe is split up into those Planck lengths. Space is one particle in the singularity and is indivisible, and every Planck point is the middle, thus canceling all gravity except the Planck length. The Higgs field is likely involved in this process. The Higgs field is likely involved in unitizing the two frames of references of two time periods. It's kind of like a transmission in a car. Automatic transmission. Entanglement explained easily. Two tangled particles reside on the frames next to each other in the black hole. Superposition and separating them is just a trajectory change of the update process. Gravity drives time, but time does not cause gravity. Too much mass excludes that mass in this space-time, and a new space-time is set for that mass, which is a black hole, better to be called a dual corpuscular reunitized time set reality. That's what it would be. So one cycle in the black hole is one click of the clock in this reality. One cycle in the black hole's super time or superposition is one click of the clock in this space-time. Gravitational wave observatory is LIGO. If you record data from a clock, a very sensitive clock, you should see a time wave from the same gravity pulses that LIGO detect, if you can make a clock sensitive enough. So you need two clocks at least. Result would be one clock in relation to the other would have a different time as the wave went through, and it would cause the time compression or dilation. Stephen Hawking and Bekenstein gave us a famous formula that tells you how many gigabytes of information you could store inside of a black hole in I'm not sure what I'm saying there. Interestingly, the newly formed black hole is a blank core. Potential information is massive. We are in a black hole core. Our space is the core. A black hole is a graviton, directly or indirectly. Electric and magnetic in an electron are 90 degrees from each other. I don't know. Some things I'm just saying. Closed-door singularities would explain lensing effect, dual corpuscular time within a black hole would explain superposition, quantum gravity, magnetism is awake. Superposition is a time out of phase, variance wake, out of phase fuzzy as awake, back in time. Experiment is dual corpuscular times with reunitized space-time due to that's a frame effect with frames and a relativistic corpuscular time and a time shared space due to excess mass and density in one position expelled from the origin singularity. Explains the flexible nature of time, the bomb experiment, the cat experiment. Micro closed door singularities would explain particles. This would explain interference patterns. Back in time test is proof that frames, meaning every base particle is in the middle of the black hole, every composite particle is also in the middle from its own relativistic point of view. Explains gravity connects to general relativity plus quantum gravity in a conceptual way never done before. In a logical